Today we are going to take a look at multiplying radicals. So in order to multiply radicals, we are first going to apply our product rule. Now the product rule states that if I have two radicals with the same index, that I can combine the radicands under the same radical symbol using multiplication. So the square root of a times the square root of b is exactly the same as the square root of a times b. And so what we're going to do is take a look at an example where you have just one radical times another, and then we'll take a look at one with coefficients, and then how to multiply binomials that include radical symbols. So the first thing we want to do here is check our index, make sure that our indexes are the same, and they are. We are taking the square root of both of these numbers. And so what my product rule says is that since my indexes are the same, I can put both radicands under the same radical symbol. So what I have done is I've multiplied, and my second step is to simplify that radical. So I'm going to start by breaking down the 27 into 3 times 9. 9 can be broken down into 3 times 3, and 5 is already prime, so I can bring that number straight down. If I look at my index is looking for a set of twins. So remember that the first twin is able to get out of the radical symbol, and the second twin is not. And since I have a 3 and a 5 left behind with no partner, both of them will stay underneath the radical symbol, and their product is 15. And so the product of the square root of 27 times the square root of 5 is 3 square roots of 15. So let's take a look at some that have coefficients. So in this case, I have the coefficient 3 multiplied to a coefficient of -2. And I also have the radicand 10, or the square root of 10, times the square root of 18. So whenever you have a radical that has coefficients, your coefficients will be multiplied together the same way that your radicands are also multiplied together. So 3 times -2 gives me a product of -6, and I have a radical 10 times 18. So I'm going to start by breaking down my 10 into 5 times 2, and 18 can be broken down into 2 times 9. 9 can be broken down into the factors 3 and 3. And since my radical has an index of 2, I'm going to be looking for pairs of numbers. So I have a pair of 2's, and I also have a pair of 3's. So in order not to lose my original coefficient, I'm going to bring it straight down, and I'm going to multiply it to each set of twins. So the first 2 gets out, the second does not. The first 3 gets out, the second does not, and I only have a 5 left behind, so I have a radical of 5. So if I multiply -6 times 2 times 3, I get -36 square roots of 5. So the important thing here is to remember that coefficients multiply to coefficients, radicands multiply to radicands. Let's take a look at multiplying radicals that include variables. So in this case, I want to start with my coefficients. So I have an invisible 1 times a 5. So 1 times 5 is going to give me the value of 5, and then I'm going to combine my radicals. So I have 6, 8, and 9 x's. You might be asking, how do you get 9 x's? My first radical had 4 x's, and it was multiplied by a radical that contained 5 x's, so I have a grand total of 9 x's. So from here, I'm going to begin by breaking down my 6 into 3 times 2. 8 can be broken down into 2 times 4. My 4 can be broken down into 2 times 2, and I'm also going to include the 9 x's that are underneath my radical as well. My index is an invisible 2, so I'm going to be looking for pairs of numbers. So I have a pair of 2's, a second pair of 2's, a pair of x's, second pair of x's, third and fourth pair of x's. So if I bring down the 5 from the beginning and I multiply it to each one of the values that is able to get out of the radical, I'm left with 5 times 2 times 2 times x to the fourth, because there were 4 groups of x's that were able to get out, and a 3 and an x got left behind. So this leaves me 5 times 2 is 10, 10 times 2 is 20, x to the fourth, square root of 3x. So sometimes when you have to multiply radicals, you have them as either monomials or binomials. So in this case, I have the product of a monomial and a binomial. So I'm going to create a Punnett square that is 1 unit tall by 2 units wide. So I'm going to have the square root of 10 and the square root of, or 5 times the square root of 5 minus 2 times the square root of 2. Now I'm going to go ahead and include my invisible coefficient of 1 in front of the square root of 10, just to help my eyes remember that coefficients multiply to coefficients and radicands multiply to radicands. So if I begin to fill in this box using multiplication, 1 times 5 is 5, and the square root of 10 times the square root of 5 is the square root of 50. 1 times negative 2 is negative 2, and 10 times 2 is 20. So from here, I begin to break down my radicands in order to simplify my product. So 50 can be broken down into 5 times 10, and 10 can be broken down into 5 times 2. So I'm going to look for pairs of numbers. The first 5 is able to get out, and a 2 is left behind. So this simplifies down to 25 square roots of 2. 20 can be broken down into 2 times 10, and 10 can be broken down into 2 times 5. So I'm looking for pairs of numbers. My first 2 can come out, and I have a square root of 5 that gets left behind. So this simplifies down to negative 4 square roots of 5. Since my radicands, the number on the inside of my radicals, are completely different numbers, 2 and 5, I cannot combine these. Therefore, my final answer is 25 square roots of 2 minus 4 square roots of 5. If I have to multiply a binomial times a binomial, so 2 terms by 2 terms, I'm going to create a box that is 2 units wide by 2 units tall. Each term will receive an edge of the box, and I will fill the box in using multiplication. So 8 times 3 is 24. And if I go back and look at my coefficients here, I can fill in the missing values with 1s. So 8 times negative 1 is negative 8 with the square root of 10. Negative 1 times 3 gives me negative 3 with the square root of 10. And negative 1 times negative 1 makes a positive 1 with the square root of 100. So right away, I can see that both of my terms along the diagonal contain the square root of 10, which means that they can be combined. So as I bring them out of the box, I will start with the upper left-hand corner, 24. I will go ahead and combine my like terms, so negative 3 minus 8 gives me negative 11 square roots of 10, plus a square root of 100. Now if we look at the square root of 100, it is a perfect square. The square root of 100 is the number 10. So I can replace the square root of 100 with the number 10. So if I combine like terms, I have 24 plus 10 gives me 34 minus 11 square roots of 10 If I needed to simplify the 10, I could, but 10 simply breaks down into 2 times 5, so there are no twins, and it's left alone. Sometimes I might be asked to find the area of a rectangle that includes radicals as part of their side lengths. So if I was going to find the area of this rectangle, I know that area is equal to length times width. And so the length of my rectangle is 4 minus the square root of 6, and the width is 7 square root of 6 plus the square root of 3. So I'm going to create a box that is 2 units by 2 units. So 4 minus 1 square root of 6 and 7 square roots of 6 plus 1 square root of 3. Coefficients multiply the coefficients, and radicands multiply with radicands. So if I begin to fill in my box using multiplication, 4 times 7 is 28 with the square root of 6. 4 times 1 is positive 4 with the square root of 3. 1 times 7 is, or negative 1 times 7 is negative 7, and 6 times 6 is 36. Negative 1 times positive 1 is negative 1 with the square root of 18. As of right now, none of these terms are considered like terms, so I'll just bring them out of the box. 28 square roots of 6 plus 4 square roots of 3 minus 7 square roots of 36 minus the square root of 18. Since I have more than one term, I am going to look at each one separately and see if I can simplify. If I take a look at the square root of 6, 6 can be broken down into 2 and 3, so there's nothing that I can do with my first term. My second term is the square root of 3, so it is already prime and is already simplified. My third term has the square root of 36. 36 happens to be a perfect square, so I can replace it with the number 6. And 18 can be broken down into 2 times 9 or 3 times 3. Since my radicand is a 2, I'll look for pairs. And the negative square root of 18 simplifies down to negative 3 square roots of 2. Negative 7 times that 6 gives me negative 42. There's nothing I could do with my first term, so I'm going to bring it straight down. And there's nothing that I could do with my first term, so I will bring it straight down as well. So now, whenever you look, you have a square root of 6, a square root of 3, and a square root of 2. None of them are like terms, and so your final answer would be negative 42 plus 28 square roots of 6 plus 4 square roots of 3 minus 3 square roots of 2.